Hello and welcome guys. So in the last video we have completed this train music genre classifier part. So in this part initially we started with visualizing single audio, and then we have done the chunking. Then we have seen that it's not like we can't put all the feature in a single graph, so we chunked it and we created spectrogram for each chunk of that audio file, and then based on that constructed this load and preprocess data function, which will take our entire data set as a path, and also will feed the class name, and also will give the target size, and it will return and give us numpy array in the form of this target shape. Okay, this is basically the matrix. Okay, so this is the shape which we are getting. So we have 14,975 training examples, and this is corresponding labels. So this function will return data and labels, and then we have performed the splitting of training set and test set, and then we builded this model, and then we train this model. So after training we are getting training accuracy as 97.29% and validation accuracy as 89.25%. Somewhere we are also getting 90% accuracy, but after 30 epochs this is what we are getting. You can add early stopping and stop at best accuracy, like here 90.55%. if there is no increment after 3-4 iteration, then you can stop here. Okay, it will consider the best thing. So you can add early stopping also. Then we have saved this model, and we have also seen the training history. So we save this training history in the form of JSON file, and later we want to reuse that model and training history. So we have also seen how we can reload our model variables and how we can reload our training history. Then after that we have done the model evaluation. So this is what we are getting, and then further we have done the accuracy and loss visualization with respect to each epoch. So this is what we are getting, and then we have computed the precision recall and confusion matrix, and also F1 score. So this is the precision recall F1 score support for each classes. This is what we are getting, and then we have computed the confusion matrix. So this is the visualization of confusion matrix. So up to here we have completed. Okay, now in this video we will do a model testing. We'll test our model. So for that, first we have to create new notebook. In this directory we have our data set, and we have this train music genre classifier, and also we have this our save model. Okay, so inside this create one more notebook here. Okay, and just select your environment. So I'm working in TensorFlow environment, so I'm selecting it. Okay, now first we have to give a markdown will be importing libraries, and first I will import OS, then I will import librosa for pre-processing part, and I will also use numpy as np, and I need this TensorFlow also, TensorFlow stf, and yeah, resize and library also I need from tensorflow.image import resize. So we have successfully imported our library. Now we will load our model. So we are loading model. So for that we have to use the same thing which we used earlier, tf.keras.models.load models, and inside this we have to give the path. So path will be this one. You can use this h5 format also. You can give the path of this h5 or keras, anything you can use. Okay, so I'm copying the path from here, and I'm giving here command v. We don't need this because we are working in the same directory in which we have our model and our this ipynb file. I'm renaming it to test music genre. Okay, so let's run this. So we have successfully reloaded our model. Now we need classes. Okay, list of all the classes. So for that we can take from here. Yeah, we have defined there. Yeah, here. So we can take directly from here. Okay, so I'm taking it from here, so we don't need to create this. Directly copy this. Okay, so this is our classes, list of all the classes on which our model is trained. Now we will do a single audio prediction, but before that we have to do single audio pre-processing. Okay, because we have to convert that audio file which we are feeding here in the same format in which our model is trained. Okay, so our model is trained on spectrogram of 4 seconds. So our test file will not always be of 4 seconds. It will be of any, like, it will be of 1 hour or 2 hour or any type. Okay, so we don't know the size of that. So first we have to do some pre-processing so that we can take that audio in the same format in which our model is trained. So I'm giving here comment as load and pre-process audio file. Okay, and here I am defining one function just like we have defined here, load and pre-process data, but here this function will be load and pre-process file. Okay, in this I will give the file path, same like there we have given the directory name, and second will be the target shape, which will be same on which our model is trained. So here also we'll use the same target shape, which is 150 cross 150. You have to put the same thing which you have put it here. Okay, so this is our file path and target shape. Now we have to define one list. Okay, this is our empty list in which we append our data, and then we will use audio data and sampling rate. It will, this librosa.load will return two things, audio data and sampling rate, and in this we will pass file underscore path, and second thing, sampling rate will be none. Okay, we want to take the original sampling rate which our model have. Here also we have done the same thing, if you see. Okay, but this we have done for entire data set, which is having a list of all the directories of class, and inside this we are having all the files, but here we are dealing with single file. Okay, so that's why we have to do like this, and then we will also set the chunk duration and chunk overlap. So we will copy from here. This is our chunk duration and chunk overlap. Okay, so we'll put here chunk duration and chunk overlap we have defined, and then we have to convert that durations to sample, and also we have to compute the total number of chunks present in that audio file. So same thing we will do. These two things we will copy from here. Okay, so same thing we will perform here also. So I'm putting here. So by doing this, we are creating the chunk samples by multiplying it with sampling rate. So it will give us chunk samples, and overlap samples. This is 2 second overlap sample. We will calculate by multiplying it with sampling rate of that duration. Okay, so this thing we have discussed in detail when I'm doing the data pre-processing part. So if you're watching from here, then please go in music genre classification data pre-processing part of the video, and you will get these things in detail there. Okay, so we are just using that thing here. Okay, so we have completed this, then we will iterate over each chunk. So right now I'm copying it from here to up to here. So I'm copying it. So don't copy this label part. Okay, because we have not defined the label list. Here we have defined this label list, but in this case we have not defined because we have to predict that. So I'm copying it up to here. So we are iterating over each chunks, and we are calculating the start indices, which will be I into chunk. This will be same, and end indices, this is also same, and we are chunking and extracting the chunk audio from start to end. This is also perfect. The same thing we have to use here also. And then we are computing the MEL spectrogram of that chunk which we have extracted, and we are passing the sampling rate, which is the original sampling rate which we obtained while loading this audio file. Okay, perfect. And then we are resizing it by using this resize functions. This also we have discussed in detail based on our target shape, and then we are appending those data here. Okay, perfect. After that we will return this. Return in the form of numpy.array. That's it we have to do. We will write here xtest is equal to, so this will be our xtest. If we pre-process it, load and pre-process file, and here we have to pass the file. Okay, but before that we have to define that file also. So I am giving here file path is equal to I will use some file from here. Okay, this is a part of training set, so we will not use that file. I already have that file. Okay, let me put that. I have already downloaded some files for you. So this is, yeah, this test music I have already downloaded. So I will copy this, and this is our demo folder. So in this I will paste it. Okay, this files I have downloaded from internet, so I'm going to use that file. Okay, so let's come here, and if I refresh it, then I will get here that file. Yeah, test music. Okay, so this is test music file. So this is some rock music I have downloaded. This is jazz music, and this is classical music, and this is hip hop music. This thing we have downloaded. Okay, so I'm going to use this rock music right now. Okay, and let's see what we are getting on this. Okay, so I'm copying the path from here and I'm pasting here, and I am removing this part, and I'm giving dot slash, and this is the test music folder. If I go here, so in this directory we have our test music genre, and in the same hierarchy we have this test music. So inside this we have this file. Okay, so that's why I'm passing like this. Okay, this is mp3 file, so I will give the path of this to this here. Okay, that's it. So we have passed our file path here, and target shape we have by default we are using this 150 cross 150 because this is the data set on which our model is trained, so we have to put this one. Okay, so I'm performing the load and pre-processing part. Okay, so if I print here, then you will see this is what we are getting. Okay, this is the numpy array which we are getting. If I do the shape, you will see this 75 chunks we have created. Okay, so it means that this if I show you the exact audio data, you can do that also. I think if I go here, okay, so we have performed this thing here, so we will perform like this, and I will show you what is the length of that audio file. Okay, so before this I have to perform that. First let me show you exactly how much is the length of that audio file which we are using. So I'm writing here playing a sound. You can play a sound using Python like this. So I'm copying this thing from here. ipython.display, we have to use this audio, and here we have to give y and sampling rate. So before that we have to define that y comma sr. Okay, so I am defining here y comma sr by using librosa.load, and here we have to give file path. Okay, and this file path I am copying from here. Okay, I am putting here also. So this file path we have to give here, and sampling rate we can give anything because this is just for loading. Okay, 44100 I am giving right now. So if I run this, then you will see what. So this sound is of 2 minutes 31 second. Okay, you can play this also from here, but I am not playing right now because of like sometimes copyrights also happen, so that's why I am not playing this. You can play, it will work. I have already played in my this train part. Okay, this audio I have already played and show you. So like this you can play from here also, it will work. Why I am showing this, so that you can understand that this much is the size of this audio file, 2 minutes 31 second. So when we are using this load and pre-process file function, it's splitting this audio 2 minutes 31 second audio into this 4 second duration, and we are taking 2-second overlap also, like we are moving 4 second, but by putting 2-second overlap we are moving forward. So this is what 75 training examples we have constructed of shape 150 cross 150. So this is our X test. Okay, now we will do a model prediction. So for model prediction, we'll write here model prediction. So model prediction part will define one function, model prediction, and it will accept X test which we have defined earlier, and we will directly use ypred, which will be model.predict X test. Okay, so if I return this, then I will show you what exactly it's giving us. If I return here ypred, and if I run this thing, see what it's giving. It's giving us array. Okay, if I do, it's returning this ypredict and it's giving me array. If I do the shape, then you will see it's giving 75 cross 10. So what is this? We have total 10 class, so it's giving probability of each class for each training example. Here we have 75 chunks. For all 75 chunks, it's computing 10 probabilities, so it's giving all possible probabilities. This is giving this thing, so we have to extract the maximum probability out of it. So for that we will use here predicted categories, defining here predicted categories is equal to np.argmax. np.argmax I am doing, and here I am writing ypred. Okay, and axis is equal to 1 I am giving. X is equal to 1 I am giving. So if I print this, then let's see what is happening. If I return this, okay, then let's see. So it's giving like this. So what is this? So it's saying that first chunk belongs to ninth index. That is, first chunk's probability will be that it belongs to 10th class. That is last class, because our index start from 0 to 9. Okay, we have 10 class, and this is the second index. So it's saying that second chunks belongs to this class. Okay, third belongs to first class, and fourth chunk belongs to this class. So this is what we are getting. Okay, if you see, majority of it are 9, and sometimes it's also 6. Okay, so what it's doing, we are splitting our audio into chunks, and when we are performing our model prediction, so it's giving me probability of that each chunk belongs to our all 10 classes, but we are extracting the maximum probability that that chunk belongs to which class. First we have to extract that. So we have successfully extracted that part. So this is what we are getting. Okay, but now this is not our final answer. This is just showing that each chunks belongs to which class. Now second thing what we have to do, we have to count how many number of unique elements are present and what is their counts. Okay, in this predicted categories, how many number of unique elements are present and what is their count. First we have to count that. Okay, so for that we will define here unique elements, and second thing will be counts. And here I am using np.unique, and in np.unique I will pass this predicted categories, and second thing will be return counts is equal to true. Return counts is equal to true. You can go to the NumPy documentation and you can see what is the how it works. So it basically take all the unique element present in this NumPy array, and it will also return the counts of that. Okay, so first we have to do this. Okay, and then we have to see what it's returning. So I will return these two things, unique elements and counts. Okay, so now let's see what it's in this function is returning. So it will return unique u elements, and it will return counts. Okay, so let's see what we are getting first. So I'm running this and I'm also running this. Okay, so first I'm printing unique elements. So this is what we are getting, and then I'm printing the count. So this is what we are getting. So it's saying that this many number of unique element exist in this predicted categories. Okay, which we have printed earlier. Okay, so this many number of elements present in this predicted categories, and what is the count of this? Count is, for 1 count is 7, for 2 count is 3, for 3 count is this much, for 5 count is this much, for 6 count is 19, and for 9 count is 37. Okay, for 9 it's saying that count is 37. So in this 75 chunks, 9 is occurring many number of times. Our model is predicting that in this 75 chunks, majority of things belongs to this 9. Okay, so what we will do now, we will extract the maximum count present in this chunks. Okay, so first we have to return the maximum value from this count. So what we will do, so we'll compute the maximum count. If I use here np.max, and I will if I give like this, so it will give me maximum count, which is 37. Okay, so we have to use this thing here in this function. So I will write here max count is equal to, I will give like this np.max. Okay, so it will give me maximum count present in this predicted categories. Okay, like here 37 is the maximum count present in this predicted categories. Now what we have to do, we have to use this maximum count and we have to return that element which is maximum. Okay, out of this unique element. So to do that, we will we'll use this unique element. So this is our unique element, and if I write here like this, if I write here counts is equal to 7, if I do, and let's see what it's giving. So it's giving me this 1. Okay, so it's saying that count is 7 belongs to this one. Okay, so it's giving me element which is unique element okay, whose count is 7. Okay, so this is what it's giving. Okay, so if I write here count is equal to 37, it will give me 9. Okay, so it's giving that count of this unique element as 37 is that this is the 9. Okay, ninth element having count as 37. Okay, so we can use this trick here. This np.unique is returning this element, and we can apply this operation on this return element by this np.unique. Okay, so this is our unique element, so we will apply this thing on this. So what I will do, I will write here max elements is equal to, we'll use that unique elements, this unique element will use, and in this unique element I will write here counts equal double equal, we'll use here max count. Okay, that is what we have to do. We have to compute the max count, and we'll pass here, and we'll say that return me that element present in this unique element list which is having maximum count, which we have computed earlier. Okay, so it will give me maximum element here. Okay, so we can return that maximum element. Okay, and if I am printing this, then let's see what is giving here. It's giving me this thing, so it's giving me array. We need that element, we don't need array, so we will give here like this 0. Okay, if we do like this, then it will give me maximum element. So we can write here by removing this is our class index. It's basically the class index, because we are using here np.argmax. It will return and give me the index of that maximum class present in that column. Okay, column wise it's extracting the maximum value, it's extracting the maximum value index, and it's giving in this predicted categories, and we are using that. So it is the index, so our answer will be in between 0 to 9. So if I print this, let's remove this because this is only a part of experiment, so I'm removing this part, and if I'm printing here C index, it's giving me 9. Okay, now what we will do, we will go here, because this is the class on which in the same pattern our model is trained, if you see in this way. Okay, so 0th index belongs to blues, 1st index belongs to classical. So same same order of class list we have used here, so we will use this. And for prediction part, what we will do, we will write here print model prediction of what, model prediction of music genre, and this is our prediction which we are getting. So what we are getting here classes, and we will pass this C index. Okay, that classes. So music genre model prediction is saying that it belongs to rock music, and it's actually rock music. If you see, it's actually rock music. So our index is saying that it belongs to 9, and it's actually rock music. Okay, so by doing this, we can do a model prediction. So we have constructed this model prediction function, and we have also constructed this load and preprocess file function. Why I am constructing it? Because later I am going to build a web application. So in that web application, it will take directly the audio file. We will give that audio file using file upload, and then we will pass that audio file. Once we click that button of predict button, when we click that, then it will execute this function first, and it will create this chunks, and it will create in this form, in this numpy array form, and then we will execute this function, and whatever this function will return, we will put in the class indices, that index will put in class indices, and we will return our output that our model is predicting that it belongs to this category. So this is our model prediction is. So here our model is predicting that it belongs to rock. And if I use some other files, like, so for hip hop also it's showing that it belongs to hip hop. Okay, so by doing this, you can do the prediction of the model. And one more thing, some sounds are like a mixture of rock music and classical music, or a mixture of blues music and jazz music. So that thing you have to see. Okay, so I have put it this file path here, so that here also I put it, so I have taking one file path, so that we have to modify only at one time. Okay, here. Okay, that's why I put it here, this file path, so that we can use that here also. So I'm saying that sometimes some sounds are, some audio files and some musics are like, which is combination of two three genres. Okay, so in that part you have to put some threshold, extract and give me all the possible C index whose count is greater than 50% of the total size of total size of our this X test. Okay, like here if it is 44, then give me all the possible sound which is greater than 20 or which is greater than 15. Okay, so that we will get maximum, like if it is combination of two three things, like two three genres, then we will get all the possible model prediction which our model is doing on that particular chunk. Okay, so if we can also deal with combination of musics, like if it is not purely classical, if it is not purely blues, or because this or data set is trained on purely blues, classical, country, this type of music. Okay, but if some musics are coming which is a combination of two three genres, like it is also in that music disco is also present, and some pop part is also present, and some rock part is also present, then for that part you have to do voting, and you have to put some threshold that this is my threshold, and based on this threshold return me and give me all possible indices which you are predicting, and based on that you can do a prediction. Okay, so here what we are doing, here we are computing this y predict, and then we are computing the indices, and then we are seeing the how many number of unique element present in this predicted categories and what is their count, and then we are performing the voting that maximum count which our model is saying that this index is having maximum count, so that will be our prediction. Okay, so this is what we are doing in this model prediction function, but we can deal with that combination of genres also by putting some threshold. Okay, so this is what we have to do in this video. So I hope you like this video and you understand that how we can do a single audio prediction, how we can feed whatever model we have trained earlier, we can use that model and we can train a single, we can give a single file and we will take a prediction. So that's all for this video. We will meet in next video. In next video we will build a web application using this model prediction function, and we will use this load and preprocess file function to build a web application, and we will display our result like this what we are getting right now. So that's why I have constructed and this entire thing in a function, so that we can simply copy paste and create our web application. Okay, so that's all for this video. Thank you guys, thanks a lot for watching this video. We will meet in next video.